I was wondering what you're waiting for. Cut! No, okay. What is that kid?
Call your phone.
That's calculus, kids. Screw that. Okay.
Oh, it's right here. I told you to hit your backpack.
So no questions from homework? All right, we'll get right back into where we left off.
Thank you.
You're welcome. So we got a little bit into graphic last time. Very little bit. I want to kind of pick up with a part of what we left off on. I have a handout today. I also brought the practice test. I figured I'd give it to you, since some of us, most of the time we have is over the weekend. So I'll pass out in a little bit. The last thing we worked on was something related to something like this here. I don't remember what we did. Remember this? And we started listing some answers, and then we plotted them. So I want to do, well, let's make this a little more interesting. We did one just like this last time, so we're in, right. Let's do it a little more interesting. Yeah.
Do you have pencil?
Let me see what you guys think about this. Some of you guys already have opinions. I understand.
Thank you.
So where is this? There it is. Okay. So let me give you this. Here's a kind of problem I would give you. What you got, Joe? No, dude. Let's do 3. 1. Let's do -1 and 5. You guys interpret what I'm asking you to do. Fill it in, exactly. That's exactly what I would say. Fill in this table and then graph the line using the points you find. All right, so let's try this out. So the really interesting thing is, the first step of this is old algebraic news. Give me a bunch of variables in something, and then tell me what some of the variables are, and I can solve for the other stuff. I mean, that's, so here in this first row, do you see how there's 4 problems here? Mm-hmm. Okay, just number them so it can stay all neat. See how that feels? So the first problem really tells me what?
Plug in 3 for x.
Yeah, x is 3. So if I rewrite what's governing this whole thing, so here I know x is 3, so then I got 2 times 3 plus y is 11. So now I can figure out the other dude. So obviously if there's an equation that's 2 variables in it, if I know one of them, I then know the other one. I like it. Okay, and what do you get?
5.
Yeah, 6 plus y is 11, so y is 5.
5.
So for an input of 3, I get an output of 5. Kick ass. All right.
Where did you get 3?
Oh, see this? So this is what I gave you, right?
Oh, you give that. That's
This
a
is
give.
what I gave you.
Oh, okay.
And then in green, I'm putting, I should have did the work in green too, but I can't think that far in. Here's what we got, the answer, right? So what's the second row tell me? So that first row is done. That's a point. I could plot the point 3, 5.
Mm-hmm.
Start going. Second dude tells me what?
Y is 1.
Y is 1. So now if I rewrite 2x plus 1, yeah, subtract 1, you get 10, divided by 2, you get 5. That's neat. All right, finish it up. Can you guys finish it up? Or some of you guys, have you already finished it up? You're doing it all in your head? Neat. I just need a way to project it straight from your brain onto a piece of paper. That'll be perfect. That'll be freaky. bad, right? I mean, the one level of this is just telling me values for a variable, and you solve for the other one. Ooh. The next level of this is, since they are connected, I can graph them and get a visual of the relationship. So in the third one is x is -1. So 2 times -1 plus y is 11. -2 plus y is 11. I get y is 13. I like it. And then finally, fourth one, 2 times 5 plus y is 11. 2 times 5 is 10. Subtract 10 and get y is 1. Is everybody cool? That's not too intensive. So x, y table, you could pick something from x and get a y, or you could pick something from y and get an x. It doesn't matter because they're related to each other. Who cares which one you got first? I like it. Now, so this is what I sometimes say. Use some of the points you found to graph the line. Because technically, how many points do I need to graph a line?
2.
Just 2. How many should you use?
Couple.
3. Why? Because in case you made a mistake somewhere, the third one, if it's over here, it's like, oh, I made a mistake. Because my line can't do that shit. Right? It's not curvy. Can't come around, oh, no. All right. But how many points do I have?
4.
Which point, if I didn't have to use it, would I not use?
-1, 13.
Yeah. Because that would make my scale a little bit freaky. All right. So, how do I plot these? Make x, y. What's this called again? Who remembers?
It starts with
You were all looking for the guys. Remember, it was who that was looking at the fly on the ceiling? Descartes.
Descartes.
Cartesian, I love it. Yes.
I like that more.
What is it?
He made up a name, but it was pretty good.
Oh, okay. What's my output? 5. I got an input of 5 and an output of 5. So it's the most exciting thing in the world, watching somebody make it. All right. Now I have to plot these 3, 5. How do I get there? Where do I start?
Over 3, not 5.
Start here in the middle. Over 3. 5. Bam.
5 couple.
5. 1. Bam. I don't want to do -113, right?
No.
Chose not to. I don't have to. Because how many points are on this line?
Infinite.
Infinite number. So who cares which 3 I use? It's going to be the same line no matter what. You guys?
Yep.
So what about that last dude?
It's the same point as 2.
Oh, it's the same one. Oh, that sucks. So, I'll do that first. Arrow. You can see how that -113, it definitely looks like it's headed that way. Okay. Not too bad. So, what if I did this? Here's people kind of freak out a little bit. So do the same thing, but you pick what values to use here. What you got, John? Well, this is a little bit evil. I mean, not make it too evil. No, it's not too bad. Screw it. So you get at least 3 points created. The last one was easier because I gave you some to start with. You've got to give yourself something. Technically, it could be just random, but in general, what I pick is like -1, 0, 1, or good inputs. Do you see why in this case, why wouldn't I want to give y a value? Because what am I going to do when I'm trying to solve for x? I'm eventually going to have to
Divide by 4.
yeah, and if I pick something here that makes something that 4 doesn't go into, I'm going to get some disgusting answer that I can't graph by hand too easy. But if I put a bunch of inputs of x, how do I solve for y? Just subtract that number. So I'm not going to get decimals then. That might be difficult to graph by hand. Maybe. So in general, with lines, you just need 3 points. And I would actually use those 3 unless their outputs come out to be like 280. And now let me try another one. So one of these outputs might not be something we necessarily want. So you might want to do one more input. Try to get these 3 at least, and I'll see where you guys get. Catch up to you guys. So problem number 1. So you can see this one's going to get a little bit, not crazy big, but you get 9, which isn't terrible as long as you pick a good scale. So on the test, there will be several problems where you have to pick your own scale. What could scale? The scale could go by 2s, 2, 4, 6, 8, each tick mark. Does the scale on the x-axis have to be the same as the scale on the y-axis?
Mm-hmm.
No.
What?
Not at all. We've seen shit like this before. I mean, we've got 2001, 2002, and in 2001, there were 3 billion people who played golf. And then 2002, there were 3.5 billion. Are these scales the same?
No.
This is going by 1, and this is going by 500 million. But as long as each axis scale maintains the step size, does that make sense? The absolute worst thing to do in a graph, and I see this all the time, especially when I teach stats, is I'll see this kind of thing.
Bless you.
Thank you.
Whatever. This is a straight line. What? So it's 1. Now it's 3. Now it's 1 again. Now it's 6. I mean, you guess so. Your step size has to stay the same, or else you're being deceiving, right? You're being dishonest with what the picture looks like. Okay, maybe. Yeah. So what if I use 0? Why is 0 nice? Because then y is 5. 4 times 0 is 0. It's dead. So an input of 0 is kind of like, yeah, I'm going to almost always do that shit. Right? So 0 plus y equals 5. Y is 5. Yeah. And what do you get when you put a 1 in? It's I'm like going too fast. Everybody with me? I'm just, where'd these come from? That was my suggestion to you, the main 3 to try. You want negatives, 0, positives. So these are a good main 3. If your outputs are kind of grosser than you want, then maybe you want to try some other ones. Or make a good scale so these will all fit. You can do either one. When you play, oh, yes.
So you need to check these numbers before you go.
Check them, what do you mean?
When we put like x minus 1, negative 1, and 9. So we need to check if it works or not? Or
Well, this is what tells me it works. You could put a negative 1 and a 9 and see that it works, but it's just like checking this. As long as you feel pretty good about what you did here, you know that those answers are correct.
so his left side should equal.
Yeah, that 9 came from putting a negative 1 in. So as long as you did this work right, that's good. But there's nothing wrong with putting both of these in here and making sure it does come out to be 5, but that's sort of the same thing as doing what we did there. Okay, I like it. So on this one, I just make x1, so we get 4 plus y. So I have to figure y is 1. No. Something I want to point out that for most of you guys, maybe this shouldn't be a big surprise. How much does the x change from here to here?
Not much.
How much exactly?
1.
From here to here, it went up by 1.
Yeah.
What did the y do?
Went down by 4.
Went down by 4. How much does the x change here?
1.
Went up by 1. What's the y do?
Down by 4.
Down by 4.
That's the slope.
Holy shit.
Oh my god.
Slope is kind of like, well, I call it the amplifier. It multiplies by how much the x changes, and that's how much the y changes. Because, now just I think this is kind of like a look forward, so this should be familiar to some of you guys. If it isn't, don't worry, we're not officially there yet. I just want to point this out right now. If I do solve this for y, how do I solve this for y?
You subtract 4x.
Subtract 4x, I like it. And I'm going to force it in front because we've already said this earlier this semester. What's the equation of a line?
Y equals mx plus b.
Mx plus b. So notice whatever x does, y does negative 4 times that much of a change. So if x changes by 1, y is going to change by negative 4. Because that's the multiplier of x, right? So if x changes by 1, y is going to change by negative 4. Okay, maybe you guys see that.
Yeah.
And that's why the slope is that number in front of the x. Right? Anyway, that's just a little preview of slope. Okay. Where am I? Oh, so now we want to see if we want to graph this. Notice how that number is not crazy, but if I want to go 5 by 5, like a standard thing, maybe I don't want to use this, but notice how these are becoming nicer. So maybe I want to try to put in there 2. This is an option yet. So if I put 2 in there, what do I get?
Negative 3.
4 times 2 plus y equals 5, that's 8. Subtract 8, negative 3, I like it. Now those I can graph really easily. But at the same time, I'm trying to not make it seem like you don't have to know how to do this. So I'll tell you what, we're going to graph all these. Haha, screw you. So if I gave you on the test something that looks like this, all blank, that's exciting. What's your x scale going to be? Look at your x's.
1.
1s, right? Because they don't go they go to 1 and negative 1, so it doesn't really matter for these other things. What's your y scale going to be?
2s.
2s is good. 3s would work too, right? Let's do 2s, why not? So 2, 4, 6, 8, 10. As long as 9 has a place to be, right? As long as 9 is in there somewhere, that's great. If I do it by 1s, 9 is going to be way the shit off the graph. It's not going to be good. So if this was 90, I might want to go by
10s.
10s or 20s. 20, 40, 60, 80, 100. Now 90's got a place to be. I like it. I like it. And then this is all negative. You could do it, Jeff. Negative 2, negative 4. Negative. Just got to be 2's all up and down. So now I can start plotting negative 1, 9. So negative 1,
Up 9.
9. 0, 5. 5. 1, 1. 1, 1. Negative. Oh, we're not going to do you. Haha. Would you say, just looking at the graph, does it have a negative or a positive slope?
Negative.
Negative. If this was the profit of my company, would I be happy or sad?
Sad.
So it's got a negative slope, right? It's going down over time. Remember the negative time? We were having a great time, and now we're, oh shit, we owe some money. Okay, maybe. Is that all right? You guys all right? All right, so let me give you this. I'm going to shut up for a bit. You guys, just kind of got everything we've done about graphing so far on this is front and back. Oh yeah. It's actually got a lot of room, so it's not crazy amount of stuff. Turn you off for a bit.